All right, happy Wednesday, period 5. Don't forget to do your daily check-in for attendance. All right, just a couple of announcements again. Be sure to watch the FAQ video on how to submit your missing work and notify me about it. If you're absent, be sure to keep up with the weekly agenda so that you don't fall behind. Know that on Thursdays, I offer extra support for Algebra 2 from 8:35 to 9:15 a.m. You can email me so that I can email you a link. And I also just uploaded a standard deviation video going over the Khan Academy problem on standard deviation of a population. So you can check that out. So tomorrow you have your first quiz in Algebra 2. Today we're going to review for your quiz. So get out a notebook, get out a pencil, and a pen. So let's start off with a warm-up. So these are the ages and years of 5 children at a local park. So here are the ages: 8, 4, 14, 16, and 8. Go ahead and calculate the following: the mean and standard deviation. So for the mean, we're going to take 8 plus 4 plus 14 plus 16 plus 8, divide it by how many values there are. There are 1, 2, 3, 4, 5 values in our data. Now you should get 50 out of 5, which equals 10. So our mean is 10. Now go ahead and find your standard deviation. All right, so here are our data values. Keep in mind, our mean is 10. So I'm going to jot that down here. Our mean is 10 because we have our values of 8, 4, 14, 16, and 8. We want to find the distance from the mean for each of these values. So we're going to subtract 10 to each of these. And what do you get? All right, so we should have gotten -2, -6, 4, 6, and -2. Well, we know that our distances can't be negative, so we're going to square each of these. And this is going to be 4. This is going to be positive 36. This is going to be positive 16. This is positive 36. And this is positive 4. Now we want to find the average of 4 plus 36 plus 16 plus 36 plus 4. Divide by how many there are. There are 1, 2, 3, 4, 5 values in this data set. You should get 96 out of 5, which is 19.2. So this isn't our standard deviation yet. Don't forget, we need to square root this value. So when we square root this value, 19.2, you should end up with the standard deviation 4.38. Or you can approximate it to the 10th place, and that would be 4.4. So 4.4. All right, so we've calculated the mean, which is 10, and the standard deviation. And it's a really long process in order to calculate the standard deviation by hand. So I'm going to show you a nice and easy way to do that. But before we go on, I just want you to know a couple things for your quiz tomorrow. We're going to hit all of these things today as we go through our review. So I want you to know how to calculate and find the mean, median, and mode, how to find the standard deviation using technology, which we're going to do in just a moment. What is the definition of standard deviation? How to read a 5-number summary, how to read a box plot, and how to find a z-score, how to find a percentile. All right, so here we go. We're going to start by solving this problem using technology. So these are the number of runs scored during the last 6 games by an MLB team. So 0, 2, 1, 2, and 5. So instead of calculating this by hand, we can go to Statlet.com, click on one quantitative variable, single group, and where it says data, we can enter in 0, 2, 1, 2, and 5. So remember, I got those numbers from here, 0, 2, 1, 2, and 5. I want to know the mean and the standard deviation. Well, there they are. You have the mean and the standard deviation. So our mean is 2, and our standard deviation is 1.871. Or approximately, you can round it to 1.9. I think that's a lot easier to do than calculating by hand. So now here's our scenario for our review today. So free throw contest. Larry and Ervin are very competitive. They competed for 9 days in a free throw contest. They timed each other for 4 minutes. During that interval of time, they shot as many free throws as they could. They counted the number of baskets each made. Below is a table of the data they collected. So here's Ervin's baskets and Larry's baskets over the course of 9 days. So what is the range of Ervin's data in terms of baskets made over the 9 days? Explain how the ranges of the two data sets compare. So in Ervin's data set, as well as Larry's data set, we found the minimum of 5. They both have a minimum of 5, and their largest value is 19. So we can take and find the range of Ervin's data by taking 5 and 19 and taking our max value minus our minimum value. Which is 19 minus 5, which is 14. And explain how the ranges of the two data sets compare. So what's the same, what's different in regards to their ranges? Well, both Ervin and Larry have the same range. They both go from 5 to 19, and their range is 14. So for 2, consider the measures of center, mean, median, and mode of the two contestants. So explain how the measures of center compare between the two contestants. So just some helpful notes. I would find the mean, I would find the median, and I would find the mode, and find what's similar and different. So remember, you have some technology that you can utilize. So if you go to Stapplet, refresh your page, and where it says data, let's go ahead and enter Ervin's baskets. So Ervin's data. So we have 5, 12, 19, 10, 12, 11, 13, 12, and 14. Click Begin Analysis. We have our mean and we have our median. So they're both 12. So for Ervin, our mean, median, and mode. So remember, our mean is 12 and our median is 12. But what about the mode? Remember, the mode is how often, the most frequent value. So on Ervin's basket, I see a 12, another 12, another 12. So it looks like 12 shows up the most. So the mean, median, and mode, they are all 12. What about for Larry's basket? What about for Larry's basket? Well, the mean should have also been 12. Your median is also 12, and so is the mode. So how do all of these things compare? So what's similar and what's different between their centers, that is? Well, the mean, median, and mode all measures of center are the same. Well, since they're all the same, let's investigate this a little bit further by taking a look at what their box plots look like. So we know from our 5-number summary that this is the median. This represents the minimum. This is the maximum. And remember, this is Ervin's basket. This is Q3, the edge of this box. And this is Q1. So likewise with Larry's basket, here's the minimum. Here's the maximum. Here's the median. Q1 and Q3. Well, on Ervin's basket, what are these dots? Well, these dots are outliers. Knowing that those dots are outliers and looking at the range of these guys, explain any significance you see between the two box plots. So what's similar and what's different? So looking at this, first off, the medians are the same. The minimum and maximums are different. But a couple slides ago, we thought the minimum and maximums might have been the same when we found the range. But what we notice is Ervin has outliers. Those we thought were the minimum and maximum for Ervin. But Ervin has outliers. And Larry doesn't. And then the IQR, meaning quartile 3 minus quartile 1 for Larry, and Ervin are different as well. Different. There we go. All right. So calculate the standard deviations of the two contestants' data sets. So go ahead and do that using your technology, or you can do it by hand. So remember, we're going to go to one quantitative variable single group in Stapplet.com. In data, I'm going to start with Ervin's basket. That's 5, 12, 19, 10, 12, 11, 13, 12, and 14. Be sure that's right. We have 5, we have 12, 19, 10, 12, 11, 13, 12, and 14. Begin analysis. We can see the standard deviation is 3.674. So 3.674. We can round this. And I'm going to round to the nearest hundredth this time. So we look to the right and we see that this isn't greater than 5, so it's going to stay as 3.67. And now what about Larry's basket? So we're going to go back over here and I'm going to erase Ervin's data and enter Larry's. 18, 12, 5, 17, 12, 7, 19, 12, and 6. Okay. And Larry's standard deviation is 5.244. 5.244. I'm going to round to the nearest hundredth like I did for Ervin's. I look to the right, it's not greater than 5. So it's 5.24. So we found our standard deviations. All right. So here's Larry's basket. We're going to look at Larry's basket specifically. So given the mean 12 and the standard deviation 5.2 for Larry's basket, how many standard deviations is 19 away from the mean? So we know that the mean is 12 and we can see that here. And here's Larry's 19 baskets on the number line. Well, the first thing we want to do is how far away is 12 from 19? Well, 12 is, we can take 19 minus 12, and that is 7. So 19 is 7 units above the mean. So since it's 7 units above the mean, we're going to take 7 divided by our standard deviation. And our standard deviation is 5.2, which you should get 1.34. So 19 is 1.34 standard deviations above the mean. So we will conclude our review by going over a percentile. So here we're talking about Larry's basket again. So Larry scored 7 baskets on day 6. What percentage of the scores are less than 7? Well, this doesn't matter. But here's 7. And we see that 5 and 6 are both less than 7. So 2 of our values are less than 7 out of the 9 total values that we have. You should get 0.22, which is 22%. Because remember, we moved the decimal place over 2 times. So 22% of the baskets are less than 7. So be sure to get some rest tonight. You've got this, and good luck on your quiz tomorrow.